In this walkthrough, you will learn how to integrate an API into an existing Azure Function App written in Python to scan new Azure Blob Storage uploads for viruses, malware, and other threats directly after they enter a container. We will be using the Cloudmersive Advanced Scan Azure Blob API to scan our files. This API is one of several variations of the Cloudmersive Virus Scan API, and it uses signature-based malware detection and deep content verification to uncover an extremely wide range of file-based threats. We can find all the code and documentation we need to call this API on the Cloudmersive API console page. We can simply scroll down this page, locate the Advanced Scan Azure Blob Storage window, and then locate Python code examples in the bottom section of that window. This API accesses the contents of an Azure Blob Storage container directly using information we supply from our Azure Storage account. That means we don't need to download file bytes at any point before consuming our API call. With our serverless Python function app listening for new blobs entering a container, we already have all the information we need. We just need to implement code that triggers an instance of the Advanced Scan Azure Blob API with the connection string credential, container name, and blob path from our storage account. To be clear, this will not be a walkthrough for setting up an Azure Function App. We will only be demonstrating how to integrate the Advanced Scan Azure Blob API with an existing function app that already observes new Azure Blob uploads. Without any further ado, we're going to jump over to some example code now. As we can see, I'm working in VS Code on a virtual machine, and I've already created a project called Scan Azure Blob Storage, which has a Python file called Function App. Right now, all this code does is trigger when new blobs are uploaded to a storage container, log the trigger event after it occurs, specify the size of the blob that triggered the event, and then start retrieving and formatting details from my storage account. My connection string is retrieved from an environment variable and stored to a local variable. And then my full blob path is split up so I can retrieve my container name and my blob name independently. Once again, what we see here is all the information we need from Azure to trigger our Cloudmersive API call. What we're going to do now is create a Python function within this app that houses our Cloudmersive Scan Azure Blob Storage API code. We will structure our API call using the code examples we saw earlier on the API console page, and we will call our API function right below where we've assigned the blob name in a container variable. Before we implement any code, however, we'll first need to install the Virus Scan API SDK in our environment and update the requirements file in our project. We'll take care of that now. We will find the pip command we need on the API console. We will copy this command to our clipboard, and then we'll head back to our Function App terminal and run it. I've done this once already in my environment, so the terminal is telling me the requirements are already satisfied. Once installation wraps up, we will head into the requirements text file Azure Functions generated in our project and specify Cloudmersive Virus API Client underneath Azure Functions. Note that you may need to run a local command after making this change to ensure your local environment reflects the updated requirements. Now we will head back to the API console, and we will copy the imports at the top of our code examples. We don't need the print function import unless we're on Python 2, and I'm running 3.12, so I will be skipping this one. We will head back to our environment, and we'll then paste these imports below the OS import in our file. As a quick note, if these SDK imports aren't recognized right away, we can try refreshing our window or reopening the application entirely. We've just imported the Cloudmersive Virus API client and a custom API exception class. From here, we can create and build our virus scanning function directly above our blob trigger function. In this example, we will create a function called Cloudmersive scan blob, which takes 3 arguments. These arguments will be our Azure connection string, our container name, and our blob path. To implement the code for our function, we'll head back to the API console one final time, and we'll copy the remaining code examples that we see below the imports. We will then paste these in our new function and handle any formatting discrepancies that occur right after that. This example code creates a new instance of the configuration subclass and then assigns its API key attribute to a placeholder string. We need to replace this placeholder string with our own Cloudmersive API key to authorize our API requests. The most secure way to do that is to save our API key as an environment variable in our Azure Function settings. When I jump over to my environment variables page in Azure, we will see that I have a variable called Cloudmersive API key, which stores the API key string that I'm using. To access variables like this in our function app, we just need to assign the API key attribute to an OS method call, os.environ.get. We will get the variable value using the name we assigned it, which in my case is Cloudmersive API key. If we don't have the OS module imported, we should add that at the top of our file now. Moving on, down in the variable declarations here, we can just get rid of these connection string, container name, and blob path variable assignments since we've already designated these as function arguments. Below that, we'll also notice we need to fix each instance of the true boolean with the uppercase version. Each of these variables here corresponds to a non-malware threat type the API automatically treats as a threat, like executables, scripts, macros, and so on. Down at the bottom, the restrict file types variable allows us to whitelist file types and block all others, but we should empty out that string now if we aren't planning to use it. If we don't empty it out, the placeholder text will become our whitelist, and that means the API will think every file we scan is unsafe. Now we will look at actually calling our API instance. As we can see here, the example code assigns an API response variable to the result of calling our API instance. Right after that, it wants to use pprint, which we imported with our example imports earlier, to format that object in our terminal. This will print to our function app log stream OK, but in this context, logging is the better way to format content. VS Code should have automatically imported the logging module when we created our function app, but if not, we should import that now. We will then replace our pprint formatted API response with a logging info formatted API response within the try except block. After that, it's likely that we'll want to make our error handling a little more robust than what we currently see here. This is optional, but I'm going to replace the example code in my app with some separate pre-formatted code I wrote to log API exceptions and other issues in the log stream when errors occur. This just makes debugging function apps a bit easier from the log stream window. Once we're happy with our error handling, we will write our function call into the trigger function, making sure we pass our connection string, container name, and blob path as arguments in the correct order. We're now going to save our file, and then we're going to click on the Azure tab in VS Code. From there, We will navigate down to our Function app and deploy the code we just wrote. Once Azure tells us our deployment is complete, we will test our updated function by uploading a new file to our Azure Blob Storage container. In order to test this efficiently, we will want to make sure that we have our Function app log stream open in another tab so we can monitor changes immediately after uploading our file. Our Function app should pull the Azure Blob container for new events, and eventually, it should find the file we uploaded. After that, it should pass the file to our Advanced Scan Blob API instance through our trigger function. Since we use the logging module to display results from our API response object, we should see the response object from our API call populate in the log stream with the information tag, just like mine has in this example. As we can see, this is a very robust response object with a ton of useful information about the threat profile of the file we uploaded. We haven't told our application to do anything with this code yet, but that's the easy part. We can access attributes from this response object directly to create conditional workflows in our Function app, such as deleting blobs or moving clean blobs to a secondary container. And with that, we've concluded our walkthrough. If you have any questions after following along with this video, I would encourage you to reach out to a member of our sales or support teams. They will be more than happy to answer your questions and learn more about the specific use case you envision for your Azure Storage account.